Our lesson to begin our trig chapter is actually going to be a review from your geometry. So we're going to talk about right triangles and our trig functions associated with those right triangles. So first we're just going to concentrate on the parts of the right triangle. So remember, you have an angle, which is not going to be at the right angle, so that's your point of reference. And then these are all right triangles, so there's going to be a hypotenuse, and then an adjacent leg, which is next to your angle, not the hypotenuse though, and then an opposite leg. So at first we're just going to concentrate on the function of tangent. So we're going to write it as tangent and then whatever the angle's name is. Sometimes it's a letter A or B or W, sometimes it's theta, sometimes it's x. But his ratio formula is the opposite leg divided by the adjacent leg. Remember, probably from geometry, you saw something like SineCosine, or I know some other teachers do Oscar had a handful of apples. So tangent of A, this is your reference point, this is where you're standing. Remember, tangent is opposite over adjacent, so 4 is what is opposite of you, and 3 is the adjacent side. So your tangent ratio for this triangle from angle A would be 4 over 3. Now, that ratio is actually a decimal as well, if you'd prefer it to be written as a decimal. Generally, we have to type things on the calculator to get the values for the angles or the sides, so we usually just leave things in fractions and then just type them in like that. So this time we're at angle W, so tangent this time, remember, it's opposite over adjacent. Adjacent is next to you, but not the hypotenuse. So 5 over 12, and that decimal ratio instead of a fraction is 0.42. Tangent of T this time, we're standing at angle T. Remember, it's opposite over adjacent, so 8 over 15, which his ratio as a decimal is 0.53. Next, we have a triangle. We're not going to solve this, we're just going to set up what we would have set up to solve it. So the angle they gave us is 41 degrees, so we'll say the tangent from 41 degrees is opposite over adjacent. So the way our triangle is labeled, that would be x over 14. Don't worry about solving, we're just setting them up. This problem, our reference point is right there at 71 degrees. And remember, it's opposite over adjacent, so we'd set up 20 over x. And in this problem, our reference point is at the 42 degree mark. So remember, opposite over adjacent for tangent, so it would be x over 16. Next thing I need you to do is grab your calculator, and you can get an online calculator if you don't have one with you. And it doesn't have to be a fancy calculator, just a scientific one. And first thing we want to check is that we're in the right mode. So go to the mode button, and you want it to be in what's called degree mode. So I'm going to have to scroll down and over and highlight degree. Okay, back to your home screen now. And they want you to type in tangent of 60, tangent of 32, tangent of 15, tangent of 86. So you just type the tangent button, and I already forgot what the first one was, 60. And when you type in tangent of 60, it's going to, and I didn't close the parenthesis, it doesn't matter because there's nothing after that calculation. So it looks like this tangent of 60, the ratio is 0.32. 320, because it wants to round to the nearest, whoops, thousands place. Okay, so if you typed in the tangent of 32, you'd hit tangent, and we get the ratio of 0.661. So I'm sure you get the idea. I'm just going to move on to the next part. Okay, we're going to set up our tangent ratios, and we're going to go from the opposite angles. So first we're going to set it up at x. So remember, tangent is opposite over adjacent, so it'd be 3 over 3. Now since this is a ratio, if it does reduce, you want to reduce it. So this is actually a ratio of 1. Tangent of y, however, would be from this angle. A little wonky right there. Okay, so let's see, tangent of y would be opposite over adjacent, which again is 3 over 3, or it comes down to a 1. Okay, tangent of g would be opposite over adjacent, so 8 over 16, which we know reduces to a 1/2. Now look what happens when I switch angles. You didn't really notice it on the first problem because they were both 1. Opposite over adjacent would be 16 over 8, and did you notice that when I switch the angles, my tangent becomes the reciprocal of the previous answer? That will always happen. That's actually a property that they like to ask on the ACT in some really roundabout, strange way, so if you know that property, you're in good shape. Tangent of P would be opposite over adjacent, so 7 over 24. Good news, that does not reduce. tangent of Q, we already know this, but it'd be 24/7. So now the next couple problems I'm actually going to have you set up and we're going to solve for the missing variable. So this is your reference point because that's the angle we have, and we can see that we have the opposite and the adjacent, so I have to set up tangent of 30 equals opposite over adjacent. Now you want to write this rule down somewhere on your paper. If x is on top of the proportion, then you just simply multiply. Whoops, that is M-U-L. Multiply. But if x is on the bottom or on the denominator, what you're going to type in is you're going to take whatever that number is, so we'll say it's the leg, and you're going to divide it by the trig ratio, or the trig function, I should say. And it has to go in that order because remember, division is not commutative, so we have to be very careful in the order in which you apply it. So we can see that x is on top. So on our calculator, we're just going to type in, and it's best if you do the leg first because you don't have to worry about parentheses then, 100 times the tangent of 30. So if you go ahead and type that on your calculator, and we did that, let's see, looks like we get 17.3 because they want us to round to the nearest tenth. If you reverse the order and you did tangent of 30 times 100, just make sure that you close that parenthesis after the 30, otherwise it's going to keep taking the tangent, which is not what it asked you to do. Okay, number 15, there's our point of reference. So again, we're going to set up the tangent of 70 this time, opposite over adjacent, so x over 18. Since x is on top, this is a multiplication problem. So you're going to type in 18 times the tangent of 70, and looks like we get 49.5. I'm not showing you how to type it on the calculator because I'm sure you can handle it, and frankly my calculator is really annoying to use. Okay, number 16. There's your point of reference, and we have opposite and adjacent, so we know we have to set up tangent. And then this time it's 4 over x, opposite over adjacent. So notice the number is on top, which means this is going to be a division problem, and when you type it on your calculator, you'll type a 4 first, and then divide by the tangent of 55. You could go through actually solving the proportion by cross-multiplying, but most people find that it's a little tedious, and if you just remember the rules about when to multiply and when to divide, it's a little easier. Okay, number 17, looks like we've got tangent of 28 degrees is 10 over x. So again, since the 10 is in the numerator, we're going to have to divide. And it won't matter if you close your parenthesis after the 28 because nothing's following it, but on your calculator, I think we get at 18.8. I should be labeling all these. I'm sorry. Okay, number 18. Let's see, tangent of 58, opposite over adjacent. So again, so since 15 is in the numerator, we're going to type in 15 divided by the tangent of 58.
I'm a ridiculous. My mom's gonna kill me.
So on my calculator, I get 9.4. Alright, number 19, there's your point of reference. So we have the tangent of 25 equals x over 15. This time we're back to having x in the numerator. So we are going to multiply. 15 times the tangent of 25. Again, if you wrote tangent of 25 first, it's fine. Just make sure you close that parenthesis after the 25. So we get roughly 7.0 when we round to the nearest 10th place. Okay, applications. This is what the trig ratios are really used for, so let's get to it. We have a person standing 30 feet from a flagpole. So here's your flag, and the person's over here, and his distance between would be 30 feet, so we'll label that. And he can see the top of the flagpole at an angle of 35 degrees. That's called the angle of elevation when you're on the ground looking up. Label the x for the height of the flagpole, so there he is. And now let's find the height. So we can see that this is our point of reference, and we do definitely set up tangent. So tangent of 35 equals x over 30. Since x is in the numerator, we end up multiplying 30 times the tangent of 35. And, oh, I didn't type that one in. Let me grab my calculator. You already have the answer. Whoops. It's 21 roughly. And looks like it's feet. Get in the habit of labeling. It's a good habit. Okay, so that was all concentrating on the tangent ratio, but there's two other ratios that we need to talk about, sine and cosine. So remember, so ka, tawa represent all three, and you have to have these memorized. I will not give you the functions. So sine of w, this is your point of reference at w. Sine's formula is opposite over hypotenuse, so when I look at my triangle, this is opposite and this is hypotenuse, so his sine ratio would be 4 over 5. The cosine ratio is adjacent over hypotenuse, and he's adjacent to w, so that would be 3 over 5. And then the tangent of w would be opposite over adjacent, which of course is 4 over 3. Now we're going to do that same figure, but this time I want you to stand at angle T as your reference point. The hypotenuse is still the hypotenuse, but the opposite and the adjacent legs have now switched. So sine of T should be opposite over hypotenuse for T, and that would be 3 over 5. Cosine of T would be adjacent over hypotenuse, so that's 4 over 5. And tangent of T would be opposite over adjacent for T. I want you to notice some similar things going on here. The sine, whoops, hello. The sine, get out of there. Oi. The sine and the cosine of the two, oh my goodness, angles are the same. So the cosine of w is equivalent to the sine of t. And the same thing here and here. And then you should notice that the tangent of the two opposite angles are reciprocals of one another. And that's always going to happen. Again, those are properties of trig ratio triangles that are going to be on the ACT. And they're not going to ask them in some clean of words. You're going to have to understand what they're trying to ask you. Number 23, I kind of babied you and I told you to use the tangent ratio, but if you look at what part of the triangle you're given the opposite and the adjacent side, so you'd have to use tangent. So we'd set up the tangent of 27 equals opposite over adjacent. So remember, if x is in the numerator, you just multiply 20 times the tangent of 27. And let's see. Hold on, I already solved this. Let's see. Yeah, 10.2. Okay, the next problem, cosine. Well, we know we have to use cosine because we have adjacent and hypotenuse, and that is the cosine function. So cosine of 60 equals 8 over x. Remember, if x is in the denominator, you end up doing a division problem, and you have to type the leg divided by the trig. So on our calculator, that comes out to a nice clean 16. 25 sine, well, we knew that because you have opposite and hypotenuse. So the sine of 13 is opposite over hypotenuse, so x over 50. This is a case where you're going to multiply 50 times the sine of 13. And trust me, when you type that in your calculator, you get 11.2. Okay, 26 again, kind of babied ya. Tangent, but we knew that because we have opposite and adjacent, so that has to be tangent. So tangent of 40 equals x over 14. So this would be a multiplication problem, 14 times the tangent of 40. Let's see here, 11.7. Okay, 27, we have to use sine because we have opposite and hypotenuse, and that is the sine function. This time, since the x is in the denominator, you're going to take the leg and divide it by the trig. And that gives us 21.3. Alright, and then 28, we'd have to use cosine because we have adjacent and hypotenuse. So that would be cosine of 30 equals x over 200. Since x is in the numerator, this is a multiplication problem. And I think we get 173.2. Alright. These next set of problems, I don't tell you what trig functions to use, so you're going to have to figure that out. So let's do this together. Here's our point of reference, that's our angle. Looks like we have the opposite and the adjacent side, so I think that has to be tangent of 32 is opposite over adjacent. Since x is in the numerator, we're going to multiply 75 times the tangent of 32. And I'm going to write my answer up here. We get 46.9. That's a 6. Alright, number 30. Here's our point of reference. Looks like we have opposite and hypotenuse, so that would be the sine of 15 equals x over 86. So x is in the numerator, so we are going to multiply 86 times the sine of 15. And we get 22.3. Number 31, we've got adjacent and hypotenuse, so that's going to be the cosine function is, let's see, x over 74, so again we're going to multiply. And, 64.1. I know you're going to be tempted to not show work on this set of homework, but you need to show setup, so don't bother doing it without showing a setup. Okay, 32. We've got opposite and hypotenuse, so that'd be sine. So we have the sine of 39 equals 28 over x. Now this time the x is in the denominator, so you have to take the leg and divide it by the trig function. And when you type that on your calculator, I think you get a 44.5. Number 33, we've got opposite and adjacent, so that would be the tangent of 56 is x over 60. So I type that in my calculator, I think I get 89.0, it rounds up to. And then here, number 34, looks like we have adjacent and then the hypotenuse, which is cosine. So cosine of 20 degrees is 52 over x. Since x is in the denominator, this turns out to be a division problem. And I think we got 55.3. Okay. I think we have something else coming up. Oh yeah, more problems. I'm going to skip this set of problems if that's okay. The last thing we need to talk about is how to find angles on our calculator. Now, when you have sine of A equals 0.6427, this 0.6427 used to be a fraction or a ratio. So in order for us to solve for A, we have to somehow undo the sine function. Now, you can't divide by sine because it's a function, just like a logarithm, you couldn't divide by it, you had to undo it. So for sine, to undo it, we do what's called the inverse sine. And of course you would apply it to both sides. So you're going to type the inverse sine of 0.6427. Let's get our calculator and see what that looks like. So inverse sine is second sine. See, it's written above it in blue. And it was 0.6427. And I'm in the wrong mode. Quit. No. Alright, we have to go to degree mode. You probably got the right answer when you typed that in. And I'm going to cheat and just do second entry. There we go. So it says around in there's whole degree, so our answer here is 40 degrees. So inverse sine of this decimal, when I type that in, let's see, I think it gives me 86 degrees. Here you type the inverse tangent of 1.60033, and you would get 58 degrees. And then here you type the inverse cosine, and then they give you a fraction this time instead of the decimal equivalent. So just type it in like that, and it comes out to 16.3, but the direction stayed around and there's whole number, so we're going to say 16 degrees. So 45, 46, 47, you have to think about what you have. If this is your reference point, I usually call this angle theta, which is a Greek letter we use for angles in trig. We have opposite and we have adjacent, so I'd have to set up the tangent of, we can call it A instead of theta, is 36 over 40. So on my calculator, I would type in the inverse tangent of 36 over 40. And looks like angle A is 42 degrees, because it wants us to round in the nearest whole degree. So here, on number 46, we have adjacent and hypotenuse, so we'll be setting up cosine. I'm going to skip a step and just write inverse cosine of adjacent over hypotenuse. And I think we get approximately 25 degrees. And then here, let's see, we've got opposite and hypotenuse, so it'd be sine. So I'm going to skip a step and I'm going to say, type in inverse sine of 30 over 37, and it comes out to approximately 54 degrees.